How's that? Can everyone hear me pretty well? Let me know. Okay, this can come over a bit bigger. I don't mean print them. I mean like save them to a PDF. Is that not looking good? I was hoping this solved the problem. I mean, that's not too far off what it used to be, right? If you save it to a PDF. Print to PDF. Okay. All right. A few bits of admin. Yeah, maybe do that. That's a good idea. The sound is low. Is my mic low for those of you online, or is the sound in the theater low? I can turn my mic up a bit. The mic's low? Hello? Just out of the left ear. Hello? Oh, is it? Is that better? Hello, 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 hello. That should be better. Yep. Okay, cool. It's just a setting. Okay. Okay, cool. All right. So a bit of admin. Yeah. So someone mentioned there's been some issues with how we've been generating the PDFs. The other issue with them is that they've got like a dark background, which makes it harder for some people to write the notes. So what we found is that if you just find these, you go to the actual slides, which you can find the full list of slides on WebCMS, and I've just linked them in the chat here. If you go here and just print them to a PDF, someone was saying the landscape looks better. You get the same slides, except they've got a white background, so it's really easy to take notes. And it might not be as good as it used to be. I'll try and get the old method working again. I've got to contact Hayden. But for now, you can just save these to a PDF. Yeah. Okay. All right. So that's that. And yeah, all the lectures are there. Okay. The project leaderboard went out yesterday. I'm sure a lot of you saw in the announcement. Do you need a brief overview of the leaderboard, or do you guys have the idea? Why is I'm very low. Okay. It sounds like we should discuss the leaderboard. So I sent the link in an email to everyone. Did you all see the email? You should have received the email. So the leaderboard, so the way we mark iterations 1 to 3, is that we have a suite of tests that we run on your code base. These tests that you're seeing generate a score out of 100. This score, this final score, is your score on the leaderboard. So what we're actually doing is marking your project right now. And we're marking it every few days, and all of those marks go in a range on the leaderboard. So you can see where your current iteration 1 mark is. If you're getting 0 to 10, it probably means you haven't pushed code to master that's passing our 15312. You can see these groups, for example, most of them are passing your own tests, but not our course tests. This is probably because you're still in development and you haven't merged to master or main some code that's actually going to be passing tests. Does that make sense? But a few groups have, and you're starting to pick up marks. And as you complete functions and catch edge cases, the mark will continue to rise. And we tell you when it was last updated. So keep in mind, it's not updated every single day. It takes a lot of horsepower to go through every single project and run every single test. And congratulations to the 3 top groups. If you're thinking, how the hell do I know which group I am? It was sent to you in an individual email, what the group alias is. If you see I'm looking to the right, I'm looking to the lecture chat. Which, while you're all processing that, actually, I might change. This is something I used to do that I realize works a bit better. Yeah. Now the lecture chat's here. That's good. They're not that intensive. There's just a lot of repos. There's 700 divide 4 or 5. We have to check them out, run the tests, blah, blah, blah. You know, it's not the actual JavaScript tests that's expensive. It's the Git actions and the servers that it's doing it all. But it's also, we're not running it constantly. You can check in every couple of days. We don't want you writing code, checking the leaderboard, writing code, you should be writing, code that works. And then every couple of days you can check in with the leaderboard. Yeah. Don't worry, we time them out. Loom. Okay, are there any questions on that? I mean, I think it's a nice to have, right? So the project didn't used to have a leaderboard like this, so you would have to just, write the tests and write the and the functions, and sort of hope that everything sort of went well. And the leaderboard was just an idea to sort of give you an indication of where you're sitting in the course. Don't forget as well, the leaderboard doesn't take into account things like scaling and things like individual marks. This is just your group's component of your iteration mark for each iteration. Okay? Happy? Not happy? Chat's gone quiet. And hopefully if you're in the theater, you can still hear me. You can hear things a bit better. If you can't, I can message someone to run in. Or someone can go up to the lectern and... I don't know if you actually can turn the volume up. But let me know and I can try and get something sorted. Can I move on from the leaderboard? We have a pretty hectic lecture today. Yes, no, thumbs up. Thumbs down. All good? SB is the thing that says 0 to 10 or 10 to 20 our approximate mark. It's this one, final score. Is the final mark. Which is comprised of these two columns combined. Okay, all good. So yeah, keep that tabbed. You can continue to check that. And we'll use the same website for the other iterations too. Okay, and congratulations to stupendous letters, sense, steep, and possessive authority. Okay, I think that's it for admin. Just a reminder as well, tomorrow is the Rob Pike guest lecture. I'm really excited for it. Please come into the Science Theatre at 2 p.m. We've got a bunch of awesome questions. I'm going to collate them, rephrase them. He's going to give a guest lecture on software engineering and what he's learned, building some impressive and important systems throughout the last few decades, and then we'll do some Q&A. So it'll be a great opportunity. This is the sort of thing that you can't, like you could have a 1531 course at other universities, but Rob Pike is associated with UNSW. He's actually on the school's industry advisory board. So this is a great opportunity. You should come along. Okay. It's scary. Don't be scared. It's better than not having it, right? I think. Okay. So today's lecture is on what we're calling advanced functions. Once again, thank you to Hayden for coming up with the initial slides, and we've done some adaptations and things. So the idea here is all about, I really like this lecture, and let me explain why. So far, what we've done in JavaScript is sort of not taking advantage of all the benefits we get from JavaScript being higher level, right? So we say lots of times that JavaScript or TypeScript is a higher level language, and that means you can be more productive and you can do more things, but we've not yet sort of actually taken advantage of what that... I mean, we've taken advantage of it in the terms of that we can have untyped variables and we can do things a bit more flexibly. But now we're going to be looking at some of the things that JavaScript/TypeScript ship with that are really, really cool, that lets us do really cool things that you cannot do in something like C without a lot of libraries, and it just will never feel as good as it does when it's baked into the language. So we have powerful tools that ship with JavaScript, and in this lecture, we're going to look at four themes of them: function syntax, which the reason we introduce this is it sets us up for the later features. First-class functions. You've probably heard this term before, but you might not know what it's actually referring to. Hopefully by the end of this lecture, you're going to 100% understand what we mean by first-class functions. It's actually a very simple concept. Higher order functions, which is a more tricky concept, I find. I think so the equivalent feature of higher order functions in Python is called decorators, and they probably confused the most of my previous 1531 cohorts. They're probably not as useful as the other features, but they are useful, but they probably are the most complex. So we'll talk about those, and callbacks, which is very useful, very important. Probably will trip you up a little bit, but not too bad. So I'm really excited. This is a great lecture, and it's fun because it's all code. Okay? All right, so we're starting off with function syntax. So here's one of the confusing things about JavaScript. If we take a step back, JavaScript has evolved over time. Okay, what the language used to do is very different to what the language can do. Well, not very different, but it's changed. JavaScript is run or decided by something called the ECMAScript Foundation, which is actually going to come in relevant in a few slides. So there's this foundation of people. I don't actually know how it's organized or run, but they decide how to improve JavaScript. Just like C++ have a steering committee and all of that, ECMAScript are the organization that decide what JavaScript should become. And over time, they have addressed what people complain about with JavaScript. It's called ECMAScript. I'll put it in the chat. So what JavaScript actually is an implementation of the ECMAScript standard. It's pretty interesting stuff. So what that means, however, is that there's a few different ways to do the same thing in JavaScript. One of those things is a very basic thing like define a function. So here we have 3 variations of defining a function, all valid in modern JavaScript, and all will do the same thing more or less. So the first example, you have define a function called sum. It takes in 2 parameters, A and B, and returns, the sum of A and B. This is, I think, the oldest syntax for defining a function in JavaScript. Okay, so that shouldn't raise any questions there. What we then have here is exactly the same thing, except we're assigning it to a const sum. Now, have you seen this before? I can't actually quite remember. In this course? A DMCA script. Have we seen this pattern before? No. Okay. So what's going on here? Okay. What's going on here? This is identical to this. Okay. Except here, the name of the function is placed after the function keyword. In this case, what we're saying is, create me a variable or a constant actually, called sum, and assign it a function. This is the idea in JavaScript that that functions can be treated as variables or as data. So sum is a named variable, even though it is a constant, right? It's still like a variable. But it is a function itself. And that function can be executed. And when it's executed, it will run A plus B with these 2 parameters, A and B. So someone's asked, is that like naming an instance of the function? Yeah, that's exactly right. It's like saying, here's this function implementation, assign it to this keyword sum. And I'll show you why that's useful in a moment. And then we have what I call the ECMA or ES6 syntax. I'm pretty sure that's correct. I might technically get this wrong sometimes, but this is the typical syntax, the old syntax. This is the ES6 syntax. So I mentioned there's this body called ECMAScript. They have different versions of ECMAScript. A very significant version that came out a while ago now is called ES6 or ECMAScript 6. ES6, oh my god, not Elder Scrolls. Oh my god. That's funny. Came out in 2015. ES6 later renamed to ECMAScript 2015. And it's functionally very similar. It's actually not identical, but for the core cases, it is identical. And you can see the difference is just that because functions are very long keyword, so it takes up a lot of vertical space. It's a new syntax style where you use the arrow operator to say A, B is a function which does this, rather than function A and B is clearly is a function which does this. So you can just see it's a slightly more compact syntax. So method 1 is the old school method, works fine. Excuse me. Method 2 and 3 treat functions like variables. We know that. Method 3 is modern and has other advantages, and we'll talk about some of those advantages. So if you're writing modern JavaScript, you're always going to write it like method 3. I hate to break it to you, you probably don't want to use the older style anymore. This is just more modern, and it actually does a few things that will make your life a lot easier that might be a bit hard to explain. Okay, you prefer one? Too bad. Too bad. Okay, so what's the actual difference here in this slide? Oh, okay, of course. Then Yuchao introduced TypeScript last week. And so these are all equivalent in TypeScript, right? So we can say that A is a number, B is a number, A is a number, B is a number, A is a number, B is a number. Okay, so you've seen that before. This is nothing different. These are the 3 variants, just with types for the parameters. Is sum the return value in method 3? No. Okay, that's a great point, SB. That's a great point. Sum is not the return value. Sum is the name of a variable which refers to a function which can add 2 parameters. Okay, it is not representing the result of calling calling the function, or of calling A plus B. Does that make sense? When we get into some code demos, it'll make more sense. In fact, let's do a code demo now. So here is, let's take this one. Let's comment this out. And let's put this TypeScript code here. Now, something you'll notice if you try and run this, that sum may give you an error because sum is a built-in function name for sum. So let's just call it sum numbers. Okay, so we'll do it all in TypeScript now, okay? You should all be hopefully comfortable with TypeScript in terms of the concept. It's all the same stuff, really. So we define a function called sum numbers. It takes in A and B. Right, this is the old school method. Returns A plus B. Let me know if you can read this easily. And I can call sum numbers, give it the number 1, give it the number 2, and then I can console, or in fact, let me go let result is equal to that, and then I can do console log result. Okay, nothing here should trip you up. Let's go ts node function syntax.ts. What we should see is the number 3 printed out to the terminal, and that's what we get. Okay, I'm assuming there's going to be no questions with this, but if there are, let me know. So I'm going to continue on for the sake of efficiency. Okay, let's skip method 2 because it's exactly the same as method 3, right? In terms of that, it's interesting because we're assigning the function to a variable. And let me put it up here. Okay, so here we have sum numbers. Now, sum numbers is a variable which is assigned the function declaration, take an A, take a B, and do the following body. Yeah, that's right, AR. And it returns the sum of the 2 parameters. Now, you call it exactly the same. Sum numbers, 1, 2, log result. It's exactly the same. If I run this, we will get 3 printed out to the terminal. Sum numbers is the name of the function which is assigned this function. Okay? But, okay, here's the important part, actually. Here's the important part. This will help you, I think, SB. What is going to be printed on line 9 here? Who can tell me? What is sum numbers? So here I'm calling sum numbers, which I mean I've just given away the answer. But if I'm not calling it, what is it? It's not an object, actually. This is probably the only time. And it might actually be an object. It probably is an object. You're close, Asish. You're close. Close. That's pretty close. But what is it? It is the function. And so we can actually console log it, and it will say it's a function called some numbers. It's not going to print out the actual body of the function, but it is a function. This is what we say. This is what we mean when we say functions are like primitives in JavaScript. They are things that exist. It's a function, which means we can call it the way we call all functions. And this is giving an error because to call this function, I need to give it some numbers, some parameters. And we'll get 11 printed out. So I think I just beat you to the question, ITZ. Does that make sense? It's it's not renaming it Aska, it's naming it. It never had a name. So this is a function without a name. We're assigning it to a variable or a name. But it's more than just naming it, and future slides will clarify that. It's more powerful than just naming it. Okay, here's another cool thing that you can do with ES6 syntax functions, that you can only do with ES6 syntax functions, and that is if you have a single line body, which in this case we do, right? You can actually omit the curly braces. And you don't have return. It automatically gets returned. And so what it means is that we can have very nice and tight function declarations that don't take up a lot of space, and this will operate exactly the same. But you cannot do this if you've got multiple. So if you do A plus B, and then let's say you want to do A plus B again, you can see here it already doesn't want to help me, but if you wrap it in braces, you can definitely have a function that does something like that. It does multiple things. So if you've got a small function, which is very useful, you can do with the ES6 syntax, you can put it on one line. ES6 syntax on one line. Yay. Okay? Yeah, so short. Okay, are there any questions at this stage? How are we all feeling? Let me do a little poll. Maybe not. What about functions with no return values? Yeah, you can just, console.log. Right? Something like that. And you can see it's undefined because the function didn't return anything. So it called the function, tried to print out what it returned, but it didn't return anything. So as long as they're just normal functions. Let me not include that. Good thinking though, good question. Very good. I remember you from 1511 SB. Good to see you still kicking, still asking good questions. Oh, thank you. What's the fancy arrow extension called? It's not actually an extension, so it's an equal sign and a forward arrow, but I have a font called Fira Code, and in VS Code, or any text editor that supports font ligatures, it merges certain combinations of characters into a single symbol, and they look quite more readable to me, so I prefer it. But it does throw off some students sometimes, so thank you for reminding me. Okay, shall we move on? Put a thumbs up in the chat if we're ready to move on, otherwise I can answer some more questions. Okay, so here's a function that takes in, I think this is the example we looked at last week where Yuchao swapped the repeat and the string parameter arguments to show you why we like TypeScript, for example. So we can copy this in. In fact, I can make a new file there. Okay, so we've got this function here. So just to briefly go over it, we take in a number, which is the amount of times to repeat. We take in a string. Probably shouldn't have called it string, but whatever. We make an output string or the result string. We loop repeat number of times, adding the string to that variable, and we return it. And the function is called manyString. So if we call manyString 5 hello, we're going to get hello, 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 hello. The undefined was because I changed this to not return a plus b and do the console log. But I've put it back. So this won't return undefined anymore. Okay. So that's an example of a function that we've already looked at. How can we use what we've learned to rewrite it? In fact, we can sort of skip that process and just go straight to the new ECMAScript standard version, which is going to be... Yeah, so if you don't return anything, Han, it's going to come out with undefined. So manyString is going to equal a function, right, which does this body, const there, and yeah, that's pretty much it. I mean, it's really not much to change. And just to prove that it does the same thing, we can do that. Okay, let's go back here just because there's a question before we move on. So the question is, like, let's say we have something here. So this function now ignores the parameters and does a console log. Okay. This is going to return undefined. Whoops. And the question is, why is it returning undefined? The answer is console.log doesn't return anything. It returns console.log. It's not returning console.log the function. This would then return a function. It's calling console.log, which returns nothing. So we get undefined. Right? So console.log is a function. The result of executing console.log is always going to be undefined. Console.log does not return a value. It does something. It prints to the terminal. Okay? Anyway, we need to move on from that. All right, so we've turned that into the ES6 standard. Nothing crazy there. Okay. Kind of makes sense. Good. I've been sort of hinting at this throughout these slides. If we look at on the left here, we're just creating a string and assigning it the string Hayden. Okay. If we look at the right and we use the const keyword to say I want a constant, we could use let for variable. So we're saying, make me a constant called name and assign it the string Hayden. So allocate some memory. We're making a variable. You can see that it's exactly the same thing in this case, right? What this is doing is saying, make me a variable called getName, assign it, right? A function that takes no parameters, And that function should do this block, which is returning the string Hayden. So what's happening here? Can someone sort of see where this is going? This discussion is going? Do you want to type your idea in the chat? There's an implication to this that's different from this if this was just function getName. Yes, Loom. Yes, describes and tests use some of these concepts and the callback concept that we'll talk about later. So if we called a function that returns something, we get whatever that function returned. Yeah, absolutely. I mean, that's always been the case. When doing the variable definition, the function definition is the backend. Not quite. That's not what I'm thinking. Zefang, hopefully I said your name okay. Do we need the brackets after getName when we call it? Yeah, so this is not actually calling it. This is going to print out that getName is a function. Yes, SB, you're closer to where I'm going. Functions are stored in the same place as in memory as variables. You're right there, but you're not saying it the way that I want to say it. You're so close though. The point I want to make is that functions, when treated in this way, are variables. They are data. They're not in C, right? You've got variables and you've got functions. Oh, thank you, Hayden, for figuring out. Is that all it was? Anyway, we can do that later. In what was I saying? In C, right, you've got functions which are built into the language, and you've got you can make variables, integers, and string. Well, not really strings, booleans, and whatever they be. In JavaScript with the ES6 syntax, these identifiers, these variables, these functions are also variables, which means we can treat them like variables. And that's exactly Hayden's wording. We can treat functions almost exactly the same as variables. So for example, we can print out a function as console.log and we'll see that we're printing out a function. And this is the term first-class functions. So a first-class function is when functions are treated just like any other data type within a programming language. So C does not have first-class functions, right? But Python does and JavaScript does. And it means that we can pass functions around, because functions are variables, into other functions. And this is the part that will probably cause you an Inception-style small breakdown. But it logically makes sense. If functions are variables, we can pass variables into functions, so we can pass functions into functions. Does that make sense conceptually, at least? Yeah, function pointers are the mechanism behind things like this. Yeah, very good. Yep. In this case, right, we have this function called say hi that returns a string doing hello and then the name of the string that was passed in. And we can pass the result of that into console.log. So this will just console.log hello name or hello Hayden. But what we can now do, because we have first-class functions, is pass the function itself, not the execution of the function, not the result of the function. So I think this will be a good slide to get into VS Code. And I've got... Yeah, let's put it here. Oh no, where else did I have it? Ah, it's here. Let me put it here. Okay. All right. So let's break down this file a little bit and break your poor Tuesday 10 a.m. little minds. Not little. I don't know why I said little. Okay. Here we're making a type called formatter. which is just a type declaration for what formatter functions should look like. They should take in a string and return a string. Okay, this is just a type declaration, not a function itself, just used in TypeScript. Oh my God. I gotta stop turning Copilot on. All right. Here we have a function, and we're using the old ES6 function declaration, but that's okay. Function called brackets, which adds brackets around a string named str. Does it make sense? So you can see that here. We're making a string with an open bracket, the value of str, and a closed bracket. Yeah, I don't want Copilot to beat me to the punch, you know. I need to stamp my authority over Copilot. So if I call brackets with Jake, actually I'll do Hayden because he popped into the chat. This will return, oops. What's this going to return? Can you guys tell me? While I pour a tea from my teapot. Yeah, exactly right, May. Exactly right. Lowercase h, technically, but yeah, exactly. Right, because it's just adding the brackets around it. This is doing the exact same thing, except it's not adding brackets, it's adding a full stop to the end. All right, so it's another function called full stop. This is more of Yuchao's lovely black tea. Say hi is another function. This one's a little different. It accepts the name of a type string, and it accepts a formatter function called format. Okay, this is where if you're sort of half asleep and maybe, I don't know how many of you are even in bed. I don't even want to know. How many of you are in bed? I don't know why that's never crossed my mind. Oh God. Let's let the poll do its work. Okay, so this is the moment where if you are half paying attention, you should, snap out of it and pay attention because it's okay, good. Most of you aren't. Because it's tricky but important. In the library, that's beautiful. Excellent. A great place to be. You can also go to the science theater. And there's 20, yeah, you're not in bed. That's good. Those of you in the theater. Good job. All right, so we've snapped. We're having our moment, right? Let's end the poll. 16% are in bed. Okay, anyway, so if you're in bed, that's fine. Sit up, just pay attention. So this is a function called say hi. It accepts a name, which is just a string, and it accepts something called format, which is of type formatter. Formatter is a type, which is a function that accepts a string and returns a string. Okay? Another way we could do this actually, maybe I don't think you actually can do that another way. Maybe you can, but that's what formatter is. Maybe to make this a little easier to read, I'll put this in a comment here. So formatter is a function, sorry. Okay, it's a function which returns a string. Whoops. And then the say hi function returns a string, which is hello, comma, the result of calling the format function with the parameter name. Who's still with me? Or do you want to go to, let's actually use it and see what that does? So let me actually cut that for now. Not me. Oh, So we go const result is equal to say hi. Let's give it now. Let's let TypeScript do the work for us. A name. All right, I'm going to say hi to SB. Saying hi to SB. And I also need to give it a format function. Now, how do I do this? Well, I have two format functions. These are functions that accept a single string and return a string that adheres to our format type. So I can do brackets. Now, how do I pass this in? If I passed in brackets of SB, okay, you can see TypeScript is already telling me I don't like this, because that would be just passing in a string, because brackets returns a string, not a function. What is this? And also, this is not nice because I've duplicated this SB thing. So what do I want to pass in here? Who can tell me? The format function does not change the string. No, it just returns a new string. I'm not going to pass in FMTR or formatter. I'm not going to... Oh, yeah. Asish has got it. I'm just passing in the function which does the formatting that I want to be done. Because brackets, again, to remind you, is a function accepts a string and returns a string. Let's run this. And that's what we wanted. Hello, SB, but the SB is in brackets. It's not really similar to function overloading. It's a different concept here, Andrew. So why don't we run through what happened here, because I think it's thrown everyone off. The first thing is we've called the say hi function, okay? And we've given it two things. Yeah, I can draw a diagram. You know, in fact, I have the diagram. Like I had the whiteboard up ready because I planned on needing to do this. But thank you for... the reminder. Oh God, don't do this to me. Please don't make me do two-factor. Oh, no. My phone is the webcam. God, this isn't very secure, is it? Oh, now it's kicked it off the camera. Jesus. Are we back? We gotta love, you know, last term in 1511, Sasha got all like 1,000, maybe some of you might even remember, got like 1,000 1511 students into the lecture room, the exam room, and they went to log on to the platform to do the exam. And obviously it's an exam, so there's no phones. And then it's like two-factor or for the students. Oh, God. Okay. Lower the cam a bit. We're back. All right. Okay. You can see all my whiteboards there. Let's do... let's do this. Can I do this? Okay, well, it's not perfect, but why can't I make it wider? Oh, you know what I can do? Hello. God. Okay, that's better. Yeah, Asish, you've pretty much got it. So, okay, let me go to my little whiteboard here. All right, so let's see how I can do this. So the first thing, so we define a function here. Can you see that? Does that look okay? We define a function here. So none of those things are calling, they're not doing anything. They're function definitions. And here is when we actually start. So we're calling say hi with two things. One being a string called SB, and one being a function called brackets, because brackets is what? It's a function. It's not a function call, it's just a function. There's beeps. Oh God. Oh, hello? This has happened before. What it is. Hello? Is this better? Yeah, but I can see it is like beeping or something. Sorry, I don't know. Hopefully you can hear me okay and this is okay. Yeah, I think we'll have a better example. There's an echo. We'll have a better example of why this is useful later. But for now, let's just get our heads around it. I'll fix it later, I think. Okay, so we're calling say hi with two parameters. One is the name string and one is the format function, right? Because formatter is a function. So this is getting passed in to here. This is getting passed into here. So what's actually executing is this line. Are you still with me? You can't hear me again? Hello? It might be because I'm turning away from the microphone. So what's actually executing is this line on line 18. Okay, this should be okay. I'll get closer to the microphone. You guys are trolling me or something. The concepts get too hard and you're like, oh yeah, Jake, the mic's broken. So what's this returning? Well, it's returning the string hello. And then it's returning the execution of format with the parameter of name. Now, what did we pass into format? We passed in brackets. So we go over to brackets and we say, well, what's brackets? Brackets is a function which accepts a string and puts brackets around it. So it's going to go hello. This is going to come down. SB. In brackets, because this put brackets around it. So someone's asked, so the format name is actually running brackets name. Absolutely. Format name, format is brackets. That was passed in. Why is brackets type formatter? Because I think the reason is, we can check this. I don't think you can put that as a... Oh, you can. It's just, it's not, you don't actually need it. It's doing this. But this is probably more confusing. Do you see what I mean? How it's just complicated? It's hard to tell where it starts and where it ends. So it's just making a name for it. So it's easier to read. That's all the type is doing here. Does that make sense? So we can replace this formatter with this type here. The other reason we do this is if we use formatter in other places, we don't want to, and we change this, we don't want to have to change it everywhere. So it's very useful to say, give me a type declaration for that function shape. Why not format colon string? Because it's not a string. It's not a string. It's a function which accepts a string and returns a string, but it's not a string itself because we need to execute it. So, yeah, sorry. Execute SB. Yeah, that's right. Okay. Okay, we got some questions. Do formatters have to be the same type in and out? No. This could be a number. That's fine. We're just happening to deal with strings at the moment. Is formatter, so whoops, here. Is this a function that accepts a string? Then why do they just accept brackets? I don't know what you mean by brackets there. It would accept brackets, or it would accept full stop. This is the key here. Yeah, I didn't actually sort of show this. I can change the formatter function just by changing the variable that I use when I'm calling it. Yeah, SB's been quiet since we executed him. Okay, still confused. Which part confused you? So in this case, right, we're calling say hi. We're passing in the string to name. We're passing in the full stop function now, because full stop is also a function which accepts a string and returns a string. Can you write old style of type formatter? I don't know what you mean by that question. Yeah, in this case, like we can do lots of different things. They don't have to just deal with strings. We'll look at more examples later. Do we mainly do this formatter thing for when we have functions as parameters? Yes, probably, because we want... No, there might be other reasons. Okay. Addy, that's fine. So Addy's saying, I still don't understand why we want to do this. Like, you might start to understand how it's working, but why do we want to do this? We have later slides that'll go into that. Okay, yeah, that's what a few of you are asking. Can you scroll up to the full stop function? Yep, sorry. It's just the same as brackets, but instead of putting brackets around it, it's putting a full stop at the end. All right. I promise you, please take my word for it. Later in this lecture, we will look at examples that make these first class functions more useful. Okay, I promise. The last thing that we would do here is say that, const full stop is equal to a function which returns that string. So we can put these on one line. Okay. Even this one we can. Think of formatter, like a normal variable parameter, where we put in some string, we just replace format within the function body with the string being formatted. Maybe. It's more that it's a function that we can do something with in the body. But anyway, let's look at another example. So this is the same sort of idea. Maybe I'll make a new file here, fcf format loop. Oh, it's not going to like that because it's already defined in the other file. Maybe I will just comment this out for now. Okay, so we've got formatter there. We've got brackets there. I'll leave it like that. We got some names here in an array. We've got a function called format names. So now format names is doing something else here. So hopefully this example will start to get you thinking about why this is useful. Format names accepts a list of strings, so like names, and it accepts a format function. So a function which will format the code, the names, sorry. Okay? I can sort of describe this. So format names accepts a list of strings and a format function. I don't know what this error is here anyway, but make a new list here. We loop through the names in the old list and we add to the new list the result of calling this format function on the string name. What is the error here? Argument of type string, so name being the string, is not assignable to parameter of type never. I don't actually know what that's complaining about. Yeah, Nate's got it. Asisha's got it. Oh, is it because this wants... Oh, there we go. Okay, that was a bit weird, but it wanted the type here. Okay, anyway, a few people are starting to click, so which is really cool. The cool thing is that we can use this formatter function parameter. We can start doing lots of things with it. So we make a new string for like results. We loop over our names and we add to that new list the result of calling format on that name. Now format, in this case, is going to be the brackets function because the brackets function adheres to the format type and it's going to add brackets around the string. And we assign that to new names. So who can tell me what this is going to print out when we execute it? SB says, in C, we were able to call functions without needing to input them. So functions without parameters. If I'm remembering correctly, so why can't we do... This is a different mechanism, SB. Yeah, that's exactly right, Han. Yeah. It's an array of Hayden, Juliana, and Tam with the brackets. Okay. Here I'm going to tell you... I understand what you're all confused about. This is the challenging part. I understand it. I'm going to try explain to you why it's useful. Let's have this full stop function back. In fact, let's even just put it back to how it was. Okay? So now we've got two potential functions we can call. One called full stop, one called brackets. We've got the function here which actually calls either the brackets or full stop. Okay? And in my program that I'm working on, I don't always want to call brackets and I don't always want to call full stop. It might change. Right? So I'm going to sort of talk through the practicality of it now. Let's pretend we're not using this. Okay? Now, there's just, in some cases, we want to call brackets, and in some cases, we want to call full stop. Okay? How do I tell this function which to do? I could give it a use brackets boolean, and I could say, okay, I could do this. If use brackets new list dot push brackets of name. I could do that, okay? This is completely fine. It's going to do the exact same thing. In fact, just to prove it to you, right? Let's just... Oh, and I got to say true. And just to prove it to you, let's run this and we will see Hayden, Juliana, Tam. It's doing the exact same thing. But if it's not true, we need to do new list push full stop. Okay? And then if I call it with false, it's going to do the full stop variant. Okay, Asish, you've got it again. And this is only calling it once. What if I had to call it multiple times? I'd have to do it multiple times. Okay, but here's the other reason I was going to. What if there were three potential things that I could do? There was brackets, there was full stop, and there was stars, which puts stars around the string. What would I have to do now? I would have to go like, make this maybe some argument which has up to 3 values. It could be an integer or an enum or something like that. Not an integer, I guess a number. And then I would just say if use bracket, and this would have to be, and then I'd have to have this massive if statement here. I'd have to say if it's the third thing, do the star. Do you see what I'm saying? Whereas I can just say, rather than doing this, pass the function. Pass me, whoops. Don't tell me which to call. Just tell me the thing. Give me the thing and I'll just call it. Okay. And we get, with just one change in the parameter, we get the correct thing being executed without having to do massive if statements in the function. Because you can imagine, what if there was 50 different ways to format the string? Do we want to say, if it's this, do this, if it's this, do this, if it's this, do this, if it's this, do this? And like someone else said, what if that was, what if I had to call it in 2 different places? Then I would have 100 different function calls. Whereas just, okay, let's not do any of that. Just give me the function itself and I'll call it. Okay, chat's gone quiet. I don't know if that's a good thing or a bad thing. Are we still live? Yep. We've lost Asish. She's going back to bed. Is there a difference between... a single arrow is not valid JavaScript. So that's the difference. What is string brackets? Okay, yeah. This is an array of strings. A list of strings. Okay, it's making sense. Awesome. That's fantastic. Whew, that was a tricky one. It's a tricky concept. If you're not getting it, yeah, exactly right, Addy. It allows us to dynamically do a different thing depending on what the function itself was that was passed in at runtime. Because you can do some really cool things here. Look at this. I can do const formatters is equal to an array of stars, brackets, and full stop. And I can, so for formatter in formatters, oops. Call format names with names and formatter. Now I'm probably gonna what's wrong with this? So that should be why is it saying it's a formatter? Line 30? No, I want to pass in the individual. Oh, that's what it is. Thank you. Great. And then we can just console.log this. If this is like a little bit more advanced, if you're not sort of following this, that's okay. And I get all 3 done. So I can loop through the functions themselves, and you can imagine that I actually can't do something like this if I didn't use the functions as variables, because I would need to change the name there. Jake being confused sometimes scares me. We're all confused most of the time. If you're really, really following and you understand this, that's a great sign that you're getting this. Okay, well, I've missed some chats, I've realized. Wait, sorry. So format is just a guideline for the function should do. That's a great way of putting it. Yes, that's right. Megan, tell them about U combinator, Y combinator. Well, we're doing filters later, if that's what you're referring to. Can we have a formatter that can output multiple types, like a string or a number? Yes, you can do that in TypeScript. Cool. Okay. This is a little more advanced, because it's an array of the functions themselves, which we can then execute in the loop. Okay. Let's put that down here and bring that back, because that's what we'll commit. Okay. Whew. Oh, your brain's actually working now. Fantastic. All right, then we did a great job. Now, I know not all of you will have Okay, is there anything else we wanted to talk about here? Okay, we can make it, put it in the new syntax. That's fine. Okay. I don't know. This whole lecture must be this one slide. I don't know how I was meant to do it the other lecture. Okay. Do you want a break? I think we want a break before we keep going. Yeah? Do we want a little break? Or are we on a... Yeah, I think we all need a break. So let's do 3 to 5 minutes like you always. Go, if you're in bed, get up, shake your shoulders a bit, go for a walk, make a coffee. Yeah, a bit fried. That's okay. It's a pretty complex concept. And it's something that you've not seen before, passing functions around like data. We'll try to be gentle for the rest. Okay, 3 to 5 minutes. I'll see you soon. Okay, I'm back. Hello. Oh god, that thing is still doing the beeping, I think. Anyway. Yuchao, advanced. Are you saying that it's not advanced enough, or are you saying that it is advanced? How to use type. I think we'll do more examples as we go on in the course. How do you type the... Oh, it's a backtick. It's should be at the top left of your keyboard. Doesn't feel advanced? All right, let's go then. Let's go. Is everyone back? I mean, we're not even halfway through the slides, so... delete that. Yeah, well, we're going more functional in a moment. Okay, let's, assuming, yeah, we're back. All right, we got lots to talk about and not much time. Okay, so you guys want it more advanced? I'm guessing that's just a few people and everyone else is like, slow down, please, don't kill me. So I'm not going to kill you. All right, so we've spoken about this idea that we can pass functions around as data. Something else that we can do is pass functions around without assigning them to a variable. And this is called an anonymous... The sound has become worse? Oh god, it has to. I don't know how to... I don't know what... is with this thing. Hello? Oh, there we go. I fixed it. Computer scientist at work. Okay, so we can pass functions around, we can do things with functions. We can also pass a function into a parameter without assigning it to a variable. This is called an anonymous function. So let me give you an example in the code base very quickly. Not this one. Right? So this is another example where you might click why this is so useful. Rather than passing in stars or brackets or full stops, I can actually pass in a function itself which accepts a string and returns str in backticks, and I don't know, what's another thing we can do to this thing? I don't know, hashes. Okay, you can see here that, you can see here that I never named this. I don't have a function called hashes, for example. I just created the variable anonymously in the call to format names. That's it. That's the concept of anonymous functions. The upside, it's less code. I don't have to write a block. The downside, I can't really use it again. Right? I'd have to rewrite it. It doesn't have a name. I can't refer back to it. That's anonymous functions. Okay? Thumbs up. Anonymous functions. Okay, let's summarize first-class functions. It means, very simply, that we can treat functions in JavaScript just as we treat any other data type. It makes one-off usage more compact, more readable, and it's a fundamental component of understanding callbacks, which is very, very important. So then you might be thinking, yeah, what the hell is a callback? And that is coming up shortly. All right. Now, this is the actual, not advanced, nothing here is advanced, but some more advanced concepts of JavaScript. The map, reduce, and filter functions. These are three functions built into JavaScript. They heavily borrow foundations in functional programming. So it looks like, what was the student that said FP? Yuchao is going to be excited. And they use first-class functions as part of how they operate. So it's important that we've covered first-class functions. I love MapReduce and filter. I love using them. I love how they make the code look. I love how they cut down the amount of code we need to write. All three of them act on lists to do something over and many times in a different way. They use concepts from anonymous functions and first-class functions. So map, I think, is the best one to start with because it's probably the map and filter. I would say map is the most useful and the most often used. So map is pretty simple. Where's my whiteboard? Because I'm assuming I'm going to need to use this. Oh. Yep. I might need to use it later, but it accepts an array or a list of something, we don't know what that is, and produces a new array with the exact same size, but modifying each element in the array. Exact same size, modified elements. So let's, this is a great, this is a great way to do it. So, yeah, this problem again. No, what was the string array? Is that what it was? No. No, I can't even remember. Okay, let me run through it and then we'll get there. Okay, so we have this list of strings called tutors. So these are some of the tutors in the course. We have this function called shout, which turns a string into uppercase. Pretty simple. And adds some exclamation marks at the end. We have this new list. We make this new list here. Oh, that's what it is. Whoops. Okay, yeah. We have this new list of strings, and we go loop over each tutor in the tutors list, and call and assign shout to a new variable and add that to the list. Okay, so if we run this map.ts, we're going to see Simon, Teresa, Kaiki, and Michelle all being shouted from their base, how they were initially provided. Okay? This is pretty simple. We're just calling a function over and over and over on a list, making a new list with the exact same elements. And maybe we can just go, just to show you what we've done. So Simon, Teresa, Kaiki, Michelle became Simon, Teresa, Kaiki, Michelle, but they're being yelled. Okay? But you can see there's a fair bit of code here. I mean, we're always going to need this array. We're going to need the shout function. Maybe we could make it anonymous though. And we got this looping here. Okay, it's adding up and then we have to call it. Okay, that's probably fine. So what does map help us do? And you can already see how reduced it is. Can I shout the names for realisticness? Maybe. We'll see. Once we map it, we can do it. Okay. So map, right? Map does this exact problem, right? We said, if we look at the slides, takes an array of size n and produces a new array of size n, modifying each element according to the function passed in. So that is exactly what we're doing here. We're modifying each name passed in with some thing. And so the way we can do this is by just deleting this and just saying new tutors, new list is an array of strings. What? Oh, const. New list is an array of strings, which is equal to we call map. Oops. sorry, we get the list of tutors called tutors and call map on tutors, passing in something called a callback function. In this case, I'm going to call shout, pass in shout. And you can see that all of that code was just replaced. Much, 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 much nicer, isn't it? And interestingly, TypeScript already told us that some callback is being used here. So we can investigate what a callback is, but it's pretty nice. Okay. All right, that's map. Okay. We'll do filter and reduce, and then we'll talk about the callback component. Or do you want to talk about the callback component now? Let me think what's better. Let's keep going. Let's keep going. Okay. So that's map. It's actually quite simple. Of course, you got to tell me to do the thing I didn't do. It doesn't matter. We'll get there in a moment. All right. Reduce. Reduce is a different, same sort of family of thing, but does a different thing. So we're taking an array. So all of these work with arrays or lists. So we're taking a list of size n. We produce a new list with a size from 0 to n. So we can shrink the size of the array, but we don't modify the data. Possibly a smaller array size, but the elements remain unchanged. Okay, so what's going on here? I'm not going to run this code. I'm just going to show it side by side, and I'll run the new code. So let's say we've got an array of marks. Everyone's got a grade out of 100, and I want to know who passed the course. So I have a function which accepts the mark, and I return the mark if it's greater than 50. If it's not greater than 50, we won't see the mark returned. Remember, this is how we would typically do it in something like C. So we make a new list, we iterate over each mark. If it passes, add it to the new list and return it. Yeah, not a single HD in there. Yeah, classic comp students. Actually, no, comp students do very well. All right, reduce, filter, we're doing filter. Sorry. Filter, as the name implies, filters out the things that we don't want or the things that we do want. Keeps the things that we want. So in this case, our function is a pass, is exactly the same. It returns the mark if it's greater than 50. And all we need to do is pass that function into the filter function as a callback, and it will do what we want to do. It's pretty cool. Let me just put it, whoops. Do you guys prefer it in a new file? Maybe it's easier. Filter.ts. All right. Filtered marks. So what do you expect this will return? Can you all type in the chat what we expect this to return? While you're doing that, there's some questions. So SB says, if the mark isn't a pass with the function return undefined. Okay, no, it just doesn't return anything. It would return false. If the mark is less than 50, this returns false. Filter, each function call needs to evaluate into true or false. That's the key with filter. So this, filter will change. No, it won't change the original array. That's why we need to assign it to a new array. Does it change the original array? We can test that. Anyway. So we'll say 65, 72, 81, 56. Any time that this function returned true, we will keep the relevant number. That's exactly right. That's how filter works. If filter evaluates the iteration to true, it keeps the element. That's exactly right. So the key with a filter is that the thing that we're checking must evaluate to either true or false, or a truthy or a falsy value. You can do that. So you could say marks is equal to We can't do it in this case because it's a constant, but you could do that. Yeah, and then you can modify the actual array. That's no problem. But in this case, I'm pretty sure if we just print out marks here, that won't be changed. Yeah. So it returns the new array. It doesn't actually change the array that it was called on. Does that make sense? Okay. All right. Any questions on filter? It's very, very useful. Yeah, that's right, Han. Has to return a true value. Yep. So interestingly, we can't change it here in filter, right? We can't add 5. We would have to map first, right? If we wanted to add 5 marks, we would have to do a map or something like that. We can't change the values with filter. It's just filtering. It's in the name. All right. That's filter. Let's look at reduce. And yes, the argument to filter and to map and to reduce must be a function. That's right. Something that's called on each element in marks. Yes, you can. Yes, sorry. You can also do that. We could just do an anonymous function here. We could do a thing that takes a mark, which is a number, and that returns mark greater than or equal to 50. We can do that. Sort also works similarly. It returns true or false if the... Well, yeah, we're not talking about sort right now. Okay, reduce. Reduce is the most tricky one. So it executes something called a reducer function that you provide, that you write, just like our isPass function, on each member of the array, resulting in a single output value. So reduce always, and it's sort of in the name, right? Like if anyone's really into cooking and you make a reduction, right? You pour some red wine in a pan, you reduce it to, you take out all the water and all the other stuff, and you get left with just the purity, the single thing that you want, which could be like some sauce or flavor or something like that. And it's the same with this reduce function. We take an array or a list of elements, and we have some mechanism to cut it down to a single atomic value. Okay. So let's look at this example here. We have an array of objects in this case. And each object is a name and a mark. Amy and Bob, Cap and Dex, 55, 43, 34, 23. You get the idea. Okay, if we didn't have a reduction and we wanted to add each student's mark up. So we want to just, all we want to do is say 55 plus 43 plus 34 plus 23. We're just summing these values. It's pretty simple. We loop over each element and we add mark to the result and we print out the result. How do we do this with the reduce function? Okay, so we have the same type. We have the same idea here. We have a student, which is comprised of a name of a mark, but in this case, we're using a type, right? We have our list of students. That's exactly the same, except again, now we have them typed. And you can see instead of having to write a for loop and do the logic here, we can use an anonymous function. Sorry, we're not using an anonymous function. We first make our sum reducer function, which has to take in the previous value and the current student. So the reducer function needs to take in two elements, the previous and the current, because it has to do two things. It has to reduce by doing a mechanism over and over and over. I'll do a whiteboard for this one that will explain it. So in this case, what we're doing is we take the previous number, and I'll explain why that's a number and that's a student in a moment. We take the previous number and we add the current student's mark, so in this case it would start at 55, to that value and return it. Okay? The single value is going to be the result of calling reduce on this list of students with the sum function, the sum reducer, and we want a starting off point. In this case, it would be 0. Yeah, that's correct, actually, Yuchao. This is like the sum. But I guess he didn't call it sum because that's already called sum. So you could call it the accumulate. But I think when I whiteboard it, this will make sense, hopefully. We call the reduction, and then we will get a single value, which will be the sum of 55, 43, 34, 23. Let me get my whiteboard. And Yuchao, you're going to have to verify what I'm doing here, because I sometimes get the order slightly wrong. Okay, let's go to whiteboard. And let's get the screenshot. Oops. All right. Let's do something like this, I think. Oh, I need to be near the mic as well. All right, so we start off by calling, let's get me a pen. By calling reduce, okay? We have the sum reducer function, okay? So sum is the reducer. Okay. Maybe we can use this as our thing. Okay, and we start off with the value of 0. When this is passed into the reduce function, this is the initial value. Okay, so if we think about executing it, let's say we've got this box here. The accumulate, let's call it, is going to start off at 0. Why does the screenshot sound menacing? Oh, is it? Again. Okay, I don't know. I got to figure out what's going on with that. All right, so it starts off at 0. So all of the reduce filter map to some degree iterate over each element in the array. So it starts off with the accumulate, which is 0, and the current student, because we're calling the reduce function is calling this sum callback. So it starts off with 0, and it starts off with Amy, you know, it starts off here. So we take 0 and add 55, which means we're going to have 55 as the accumulate. Okay? Then I'm pretty sure it just goes to the next one. And it does that all again. So it takes the accumulate, or previous is still sort of accurate there. The previous sum, it's not the previous value, that's the key. The previous sum, which is 55, and it adds 43, right? And then like that slowly all gets reduced down to when you get to the total number, which I don't know what the number is, and then that gets printed out. Some can't have three arguments. I'm pretty sure. For being called as a callback for reduce. Yeah, the first previous is just 0. That's right. Yeah. You can think of it as sort of a recursive function, although I don't know if the implementation is recursive. But it does definitely have similar mechanisms, or does similar things. Whoa, what did I just do then? Okay, we're running a bit short on time. So okay, the point of this slide is just to say that you can use anonymous functions to streamline the code. Yeah, reduce doesn't always add. In this case, reduce is adding because the reducer function was to sum. This could be multiply. This could be something else. You're right? It could be anything. All right. We've already spoken about anonymous functions. We can pass anonymous functions into these map, filter, and reduce to get really nice, clean. You can see how little code there is here, right? For just 3 lines, we can filter all of our marks that are less than 50 out of our new list. No, reduce can work on more than just plus and multiply, as long as the result of 2 things, the previous and the current, or the accumulate and the current, can be derived into a single new value over and over and over again. So there's lots and lots. It could be a function call, it could be exponents, yeah, it could be lots of things. So you can sort of see here just how little code we have here. You can call any function as long as it will result with taking a previous and the current and the accumulate and the current and coming up with a single result over and over. All right, let's move on quickly. Like I said, you can have these anonymous functions. And I just want to point out, look how little code there is here to do a filter, for example. So they're very powerful functions. All right, and here we have a fun little exercise that combines all of our things that we've spoken about. So we're going to take a list of marks, right? 39, 43, 48, 24, 33. And we want to print the average mark of everyone who passed the 60-mark exam as a percentage, right? So first of all, we want to remember, so these are out of 60, 39 out of 60, 43 out of 60. So we need to get these out as percentages so we can use map, right? Using an anonymous function, we take each mark and we say times each mark by 100 divided by 60 so we can get our percentage. All right, so now we have a list of the marks as percentages. We can filter them out who passed by applying this anonymous function, which removes any mark that is not greater than 50. And then we can reduce those remaining marks, so the passing percentages, by adding them all up, right? So this is doing like a sum. We divide it by the total length and we get the average passing mark as a percentage. Yeah, RIP to the student that didn't pass. But you can see, as a little exercise, if you were to write all of this out as, code that doesn't use these concepts, how long you would be, how long the code would be, right? Okay. Pretty cool stuff. We've gone through it pretty quick. You got to get your hands on it. There's going to be weekly labs on it that'll really help you get your heads around it. And then I think the final concept for today is higher order functions. Higher order functions are called decorators in Python, if anyone's coming from Python land. That makes sense. So called decorators in Python. They're functions that return functions. They're like mini function factories. So this really just to sort of drive the wedge in at the end of this crazy lecture. Why are the labs kind of super hard? Well, because maybe, I don't know, the content's hard and you got to get your heads around it and all of that stuff. Yeah, that's right, Yukino. Lots of decorator fun in Python. Okay, so they are functions that return functions. Way harder than the lectures. Well, the lectures are about delivering the concepts at a high level. Yeah, Hayden got a credit. Poor Hayden. Okay. So let's have a look at this example. We have a function here that takes in a string, a name, and we say congratulations name on your pass because this is the congrat mark pass function. We have credit, distinction, but you can sort of see here that there's a lot of repeated code. There's a lot of repeated repetition, right? Like this is all the same in each case. And whenever we see repetition in programming, it's typically a signal that we want to remove that repetition. All right. So how can we start doing that? Well, the first thing that we need to do is to remove the commonalities between the repetition. So we have instead, right, we have these pass, credit, distinction variants of the function, but we only, we took out the thing that was unique, pass, credit, distinction. And instead, we return, rather than a string, we return a function called to congrat wrapper. Congrat wrapper knows how to combine the thing that was unique, like the string, pass, credit, distinction, and the name that is also unique at runtime. And the wrapper returns the actual string. Congratulations, Hayden, for example, on your mark as a string. So congrat mark credit or congrat mark pass is the factory that returns a function. Well, it doesn't actually return a function here. We're not quite there yet, sorry. We've just decoupled the thing that changes from the string that doesn't change by turning it into the factory. Okay, and then that's what we just had. All we're doing here is using the new ES6 syntax. So otherwise, it's completely the same. And then we can actually use the higher order function or the decorator pattern in JavaScript, TypeScript. So here it is here. It is the congratulator generator. It accepts the string, all right? And it returns, right, a function which accepts a name, which is a string, and that function returns the overall string that we wanted to generate, which is congratulations, Hayden, on your mark that was whatever it was that was passed in. And then we return the function itself. Okay? Then we instantiate, or we make 3 functions, the pass, the credit, the distinction function, okay, which pass in the mark as a string, so pass, credit, and distinction, and generate or return the sub function. So each of these contains this part. And this part, it knows the mark string that was already passed in, so pass, credit, or distinction. We don't have the name yet, but that is contained in these functions. So we can then just say, well, call the credit function with the Hayden as the name. I think this is just going to turn it into ES6. Yeah. Let's run maybe this one. We've got 2 minutes. First order funds.ts. Let's pass this in for now. All right. First order functions, and we should see congratulations, Hayden, on your credit. Yeah. Too many function calls. Yeah. But we don't know that Hayden got a credit. We know that Hayden got a credit because we're calling the congrat mark credit function. So let's break this down a little bit. What is congrat mark credit? It's a function, okay, which is labeled return, or this ret function here. So we can see here that is this. So you can imagine that is, whoops, that's not a very nice way of, congrat mark function is the function, I'm not trying to, that was returned from here, and it's contained in each of these. Where does the value of return go? It gets returned here and stored in each of these. Yukino wants us to implement what we've been talking about there. Yeah, which is a lot nicer. And in fact, we can just return that. But it's the reason I want the label here for now, just to show what's going on there. Okay. Why is congrat mark credit ret instead of gen congrat mark? Because, okay, gen congrat mark is a function that returns this. It returns ret. So that's what is going to be contained in this. Right? Sam wrote, how can you pass in Hayden to congrat mark credit? Well, I need to pass in Hayden. I was just showing here what is in congrat mark Hayden, but what we would typically do here is put the name. I could put Jake, for example. And then Jake got a credit. It's equal to the return value of the function, absolutely. If we don't label it, I'm curious, and we just return it, right? So we don't assign it to a variable, and we print it out. Okay, yeah, it just says anonymous. Yeah. I think this is a little cleaner because we can show that. That's a nice way to leave the final extra code. So that is the generated function. So if I pass Jake into it, what it's really calling is passing Jake into this function. And this is just a very simple function that goes, congratulations, Jake, on your mark. But that was already, the mark string was already set because in the credit, we passed in credit previously. Whew. So return, okay, so it's equal to the return value of the function, absolutely, yeah, but how does congrat mark credit accept a string parameter? Congrat mark credit accepts a string parameter because that is the parameter associated with the function that was returned from the generator function. Asish has just had a mind click. That's really good. Yeah, congrats credit is a variable to hold the return of this call, of this function, which is just another function. How does Jake get into Jen congrat mark? Okay. Maybe let's quickly whiteboard it. Do you want to quickly whiteboard it? And I think, let me just make sure I didn't miss anything here. I think all we're doing here is turning this into ES6. Yep. And then, yeah, this is an even cleaner one, but let me do this. Whoops. Let me do the whiteboarding. Ah, go away. Oh, so I didn't ignore it. Okay, I did miss it. How does Jen congrat credit mark, yep, know that pass is a mark string and not a name? Very simply, Jen congrat meta, if we black box this and forget what this is doing, what does Jen congrat mark accept? AR11. It accepts the mark string. That's all that's passed in here, here, and here. So that pass is the mark string, because that's what's called. This Jake is not passed into Jen congrat marks. Here's a quick tip, right? If you're ever in a situation like this and you're getting confused about what's happening where and which order, blah blah blah, the best thing to do is to black box it. Literally, this is Jen congrat mark. It's a function call. You're getting confused because what that function does is confusing. Let's just remove it. Can you understand what this is doing? I think you can. All right. Understand it, run through it, put it back. Okay. It returns a function. That function accepts a name, right? And it's stored, the result is stored in these functions. So the Jake gets passed into name. The mark string was already assigned from these pass credit distinction. Wait, but why do we pass Jake into congrat mark credit? Is it because congrat mark credit is a variable? Name the function return. Yes, that's 100% correct, Asish. 100% correct. Jen congrat mark with the credit generated a function. It passed credit in here, so it made this credit. And now it's just waiting on the name that gets passed in there. How does Jake get passed into the name string? Because this function gets returned and stored as the result of calling Jen congrat into mark pass. So congrat mark pass is like this thing, except mark string was already passed in, right? Because we passed in pass. So what does congrat mark pass wait for? A name that I'm passing here. Capital S. Right? Yeah, maybe this comment is what's helpful. So this is what actually is in this. So then when I call it here, it should make sense. When in doubt, ChatGPT it out. Is the function for them written in another code? No, it's written here. This is this. Congrat mark credit. Yeah, they're all the same. So this congrat mark credit is this, but with credit for mark string. Congrat mark distinction is this, but with distinction for the mark string. Okay, so congrat mark pass is just a function with the mark already mentioned. Exactly right. Exactly. So the function, all it needs now is the name, and it's got the two components it needed. 100%. Oh, so congrat marks pass contains the return value, which is the same. It's not the same function, but yeah, you're so close. It's not the same function. It's the sub function that gets generated. But yes, that's very, very close. It turns a thing it's stored in into a function. Yes, it's turning this into a function. That's right. I mean, what I'm describing is currying. So just giving it another name isn't going to, I don't think it's going to necessarily make this endeavor easier or harder. This isn't a functional programming course. There's other courses that go into this in a lot more depth and clarity and correctness. We're just talking about these few concepts here. What I mean is that gen congrat mark function only has credit passed in. Why do you think it's only got credit? Gen congrat mark is like the generalized congratulations function. It doesn't have anything until it's been passed here. Jake never gets passed into gen congrat mark. It gets passed into this one here. Yeah, if you can understand, that's the only. Sorry, yes. Just the feedback form right here. I'll leave that on for a second. Maybe I can actually do both. How's that for a bit? Okay, so how did Jake get passed into gen congrat mark? Yeah, like I said, it doesn't. It gets passed into these ones that contain this function, which is actually waiting for the string. I think, yeah, maybe we ran out of time, but a whiteboard might have helped. I think I get how to use it. Not quite saying how the name travels the whole process. That's probably enough for the QR code. I'll give it one more go. It's ITZ. How do you say your name? I think this comment for me is the way that sort of explains it best. So congrat mark pass calls is the result of calling this function call with pass that's passed in. So it's going to generate a function, but this string has already been populated with pass. And this function expects a name. So congrat marks pass is a function, that accepts a name and returns some string. But we don't really care what it does. We call congrats mark pass and pass in the name. So it's a two-step process. First, we set up each function with the mark string. Then we call the function we want with the name. You got it. Excellent. Look, it's a tricky concept. It's a really tricky concept. It's completely normal if you're still getting your head around it. We ran a bit over time. Apologies. Have a great day. I'll see you tomorrow for the Rob Pike lecture, which is really exciting. If there's demand for it, which it sounds like there is, we can look at making a 3 to 5 minute video on higher order functions that we put in the lecture series. Maybe I'll get one of the tutors, or I can make it myself. And we'll do like a whiteboard, and we'll talk it through a bit better, if that sounds good to people. But if you're not quite fully capturing it, that's okay. there's some labs and stuff. No, we don't have the video. I'm saying we can make it. Sorry. Okay. Yeah, and if you like, if there's others of you like Yuchao that have done a lot of functional programming before, you'll understand that this isn't exactly how the JavaScript is operating, but it's a good sort of stepping stone to getting the head around the use of the concept. Yeah, I'm saying that we can make the video. Anyway, I better leave it there. Thank you all so much. Please provide lecture feedback if you, I'll leave it up as the last thing on the slide. Thank you all, and I'll see you tomorrow for the Rob Pike lecture, which I'm really excited about. See ya.